Next, we're going to take a look at a step that you might not always need to do, but you always need to check to make sure uh, that you do it if necessary. So let's read this step together. Step 5 is going to be write an additional equation that relates to the variables if necessary. What does all this mean? Well, basically, you want to try to get your formula in terms of two variables. We're looking at example 1, where we have the tank here, and we were able to determine, since the length and width of this tank is constant, we just plug that in to our V equals LWH, and we have V equals 6H. Our equation is already in terms of just two variables, V and H. So step 5 will not be necessary for example 1. If we had three variables, we would try to relate two of those variables so that we could eliminate one of them and just have two variables left. But again, if for step 4 you were able to get down to two variables, then you do not have to do step 5. Okay, but it is important. As we saw with one of our examples that had three variables in it, we will use step 5 to narrow it down to two variables. And it just makes taking the derivative a lot easier. We don't have to use the product rule or anything like that. The product mixed with implicit. So step 5 is done for example 1 just because it's already in terms of two variables. Let's take a look at example 2. We were also able to get, again, this is the ladder sliding away from the wall. We used the Pythagorean theorem since it's a right triangle. And we got x squared plus h squared equals 25. Now, this is already in terms of two variables, so we do not need to narrow it down anymore. This will be sufficient before we take the derivative since it's just an x and an h. So again, for step 5 for this one, we can also just check it off. Again, this is only if it's necessary, if it has three variables in the equation, we need to narrow it down to two. However, for example 3, we did notice we had this cone, right? And we figured out just a few things: the rate at which the volume is changing and the height of the water level was 5 meters. These over here were just the measurements of the cone itself, so 10 meters high by the radius of 4. You notice for step 4, we wrote an equation that relates the variables, the volume of a cone, but we have three variables. So in this case, we will be implementing step 5. We want to try to eliminate one of these variables. So we can just have it in terms of two variables. Now, a lot of my students are asking me, hey, how do I know which variable to eliminate? Well, if you go back and read the question, so that's my advice, read the question. At what rate is the water level rising? We want to figure out, that has to do with H, right? That has to do with the rate in which H is increasing. So we want to get the formula down to just V and H. We want to eliminate R, since we're trying to figure out dH dt, which is the rate in which the water level is increasing. So that's how you know. Just read the question and see what it's asking. So we want to get rid of R in this equation, so it's just in terms of H. This leads us to step 5. Write an additional equation that relates two of the variables. So the two variables we want to relate are R and H. Get rid of the R, keep the H. Now, here's my formula. You're probably asking, how'd you come up with this? This goes back to the concept of similar shapes. In this case, similar right triangles. Okay, for my bottom one, I'm just going to use pink. So this right triangle is within basically the water level. And for my bigger right triangle, I'm going to use purple. Now these two shapes are similar. They share a similar angle down here at the bottom. They're both right triangles. What we can do is, if we take this bigger leg up here, 4, and divide by R, that's going to be equal to 10 divided by H. Okay? They're similar triangles, so if you divide any of their two corresponding sides, those ratios will be equal. So therefore, I can write r over 4 equals 10 over h. I think I wrote it a different way, though. You can also just take any two sides of a triangle and divide by the corresponding two sides of the other triangle. So you can also do r over h, so that one leg divided by the other of the pink triangle, that's going to be equal to 4 over 10. Okay, either way, you're going to get the same answer. It won't matter. But here we have an equation that relates two of the variables, r and h. And again, that goes back to the fact that they are similar shapes. Okay, basically the same right triangle with the same angles, just blown up, right? So, that's it for step 5. You're going to see how you use that to eliminate one of the variables. But since r and h are related in this way, another way to think about this, if you simplify 4 over 10, that's just 2/5 or 0.4. What that basically means is the radius will always be 40% of the height. Okay? So, that's it for step 5. For this example, you want to write an addition equation that relates two of the variables. That way you can eliminate one of them and just have a formula in terms of two variables instead of 3. We move on to example 4. Again, this has to do with just to refresh your memory, the coffee dripping from a conical filter into a cylindrical coffee pot. We were able to get it down to two variables because we said the radius of the coffee in this pot will not change. It's just going to be 3, half of 6. So we have V2, the volume of the coffee in the pot. Remember, V1 was the volume of the coffee in the filter. V2 is equal to 9 pi H2. So we're good to go for this one as well. We can go ahead and check this one off. All right, so if you notice, I only did step 5 for one of these, and that was for example 3, where we had to use similar triangles to relate R and H. So no matter how high this water level is, R will always be 40% of H. In other words, R over H equals 4 over 10. So that's why I say if necessary, but sometimes it really is necessary. Without this step, you would really confuse yourself, especially when you try to take the derivative with this in terms of 3 variables. It can be really difficult. Makes it much easier to write it in terms of 2, which will lead us to the next step, which is narrowing it down to 2 variables.